White noise is different from all the other signals that we've looked at up to this point. Those signals have all been periodic, meaning that they repeat and go through a cycle over some period of time. Noise is different. It's aperiodic. It does not repeat. Therefore, we're going to use a random number generator to help us synthesize this signal. After we do so, let's analyze the spectral characteristics. We're now ready to jump into MATLAB to synthesize white noise. Here are some steps that we can use for synthesizing a white noise signal. Now, white noise is aperiodic, meaning it does not repeat or it is not periodic. An approach that we can use for creating a signal that does not repeat is to use random numbers as the amplitude values of our signal. In MATLAB, there's a built-in function that we can use for generating random numbers. Specifically, we're going to use one here. It generates a random number that fits a normal distribution. This will create noise that gives us the characteristics of white noise. The input variable or variables we'll use here are the dimensions of the array we want to create. If we're just trying to create or generate a single random number, we can just put in the value of 1 here. When I execute this command, I can do it several times and see that we end up with different numbers. Some of these numbers might be positive, some of them might be negative. If we wanted to create an array of random numbers, we would just put in the dimensions here. How about a 2 by 2 array? Each element in this array takes on a random number. So when it comes to audio signals, by convention, we've been trying to create column vectors, have a bunch of rows and one column. So here, if we want to have a column vector, takes on random numbers, we could put in the number of rows we want or the number of samples that we want and one column. So let's apply this then and write a script for synthesizing white noise. So I'm going to first define some initial parameters that we'll use as part of creating an audio signal. These will be things like our sampling rate. How about 48,000? Sampling rate. How about a time in seconds for our signal? 2 seconds long. Now we need to convert this into a number of samples in our signal. So our number of samples is going to be our sampling rate times the number of seconds that we want. So it'll be our duration in samples. All right, now we have everything we need to generate some noise. So I'll put in noise here. It's going to be equal to rand_in. This is the built-in function for random numbers. Then we need to say the number of samples we want. And we'll just have one column. The next thing I'll do here is we can plot and look at the result of what we've come up with. So I'll run this script. Now we have created a signal that has 96,000 samples that take on values that fit a normal distribution, from negative to positive. Now, one thing you'll see here is that this function it's possible for it to create numbers that are outside the range of -1 to 1. But when we're working with audio and we're going to write this signal out to a file on our hard drive, we need it to fit between -1 and 1 so we don't have any clipping going on. So what I'm going to do is scale the amplitude here of our signal. So I'm going to go in here and say, how about minus 0.2 times rand_in. Let's plot the result and see if we're getting something close here. Okay, now we're fitting within our range. Doesn't go -1 or +1. So last thing I'll do is use audio write. We're going to use the file name here, white noise.wave. Then we'll put in our noise here and we'll put in our sampling rate. So generate the random numbers, scale them down to a size that's going to fit between -1 and 1, and then plot it to double check and write it out to a file. Now when I run the script, we'll see that a new noise wave file shows up in our current folder. Great. The next step that we'll do is we'll import this file into our digital audio workstation and then analyze the characteristics of our noise. Here's the white noise audio file we just created in MATLAB. This signal sounds like this. We can analyze the frequency characteristics of this signal. I'm going to pull up a plugin. This is a free one from Blue Cat Audio, and it's their frequency analyzer plugin. We can look at the relative amplitude of frequencies across the spectrum. With white noise, this is a signal that has the probability or the possibility of having equal amplitude across all frequencies. Just to double check the signal that we created, let me pull up the signal generator of white noise from our digital audio workstation and compare here with this signal generator of white noise with what we have. So on the left, what we're going to see is a signal created by our digital audio workstation with the signal generator plugin. And then on the right, this is the signal that we have created. You can compare side by side the results. So now we've been able to show that the steps that we used in MATLAB and the computer code to generate our noise, in fact, fulfills the same characteristics as the white noise being generated by our digital audio workstation.